The Biginelli reaction is a multiple component chemical reaction that creates dihydropyrimidinones or dihydropyrimidine thiones from enolizable carbonyl, aldehydes, and urea or thiourea. In 1893, Pietro Biginelli reported a combination of an aldehyde, beta-ketoester, and urea under acid catalysis to give a dihydropyrimidine. The reaction can be catalyzed by Bronsted acid or Lewis acid such as copper trifluoroacetate hydrate and boron trifluoride. Several solid phase protocols utilizing different linker combinations have been published. Dihydropyrimidinones are widely used in the pharmaceutical industry as calcium channel blockers, antihypertensive agents, and alpha blockers. Biginelli reaction. If we want to generate dihydropyrimidinone, we need urea. If we want to generate dihydropyrimidine thione, we need thiourea. Besides like urea or thiourea, we need an aldehyde and enolizable carbonyl in presence of an acid and heat. Now let's understand the mechanism. Let's consider this aldehyde and this enolizable carbonyl. Both are reactive, but you know that aldehyde is more reactive, so the reaction is going to be with aldehyde first. We have an acid, so that oxygen, which is electron rich, is going to abstract that proton, become protonated. Now you have generated an electrophile, and the electrophilic site is this carbon. So you have this amine, which is a nucleophile. So it has electron to give, so it's going to attack that electrophilic site, push that electron density towards that oxygen, forming this. Now you have a protonated amine and you have hydroxyl. So proton transfer is going to happen. You're going to generate water, which is a good leaving group. So that nitrogen is going to push that electron density, forming that bond, and is going to expel that water out. Now you have generated iminium ion. Remember, we also added an enolizable carbonyl. So that's going to get protonated. Water is going to come in, abstract that proton, and it's going to form this enol. And now this enol is going to act as a nucleophile. So we know that when enol has to act as a nucleophile, it happens through this pi bond. So that pi bond is going to attack that electrophilic site on the iminium ion, and it's going to push the electron density towards that nitrogen. Now after that, this is a key step. This is a rate determining step. And you're going to get an intramolecular aldol condensation. Now the question is, which is more favorable, 6-member ring or 4-member ring? The answer is 6-member ring. So we're going to generate, so this amine, right, in comparison to this amine, is going to be more reactive, and we're going to generate this 6-member ring. Now after that, we still have an acid, or it's an acidic medium. So that hydroxyl group is going to grab that proton, become protonated, and now you generated a good leaving group. So that nitrogen is going to push the electron density, forming that bond, and it's going to expel that water out again. Now you have generated iminium ion. So the water is going to come in, abstract that hydrogen, right? And it's going to push the electron density towards that nitrogen, forming this dihydropyrimidinone or dihydropyrimidine thione, depending on if you're using sulfur or oxygen. So that's all for Biginelli reaction.